Okay, so just very simple, this tracer balance equation. Let's see. So tracer balance problem. So what's given is the half-life of 1/1580 minutes. So T half-life as 1/15/180 minutes. So based on the systems approach, as a accumulation equals influx minus outflux plus generation minus consumption. So here we know the influx is 0 over like when time is bigger than 1 and generation consumption is 0. And this becomes the mass of the change of the mass inside the system will be minus Km. Okay, or we can change it into concentration using C. Then that's so you can change this dC over dt is equal to minus Kc. Then we can solve this problem by the 1. So 1 we can solve it because exponential function is differentiation gives itself. So this, the answer is C. T will become C times 0 times e to the minus KT. So based on the half-life definition, we can calculate C over T half-life will become 1/2 C0 becomes C0 times e to the minus K tau. Let's say tau is a half-life. Then this will lead to 1/2 will be e to the minus K tau, or we can solve it by taking a log of left and right side, then minus ln 2 equals minus K tau, or the tau will be ln 2 divided by K. So if this is what we know, or we can now write down K equals ln 2 over the half-life. Okay, and then we can now have these CT equals C0 times e to the minus KT is, let's say, 2. And let's take a log of 2. Then what will happen? So log ln of CT becomes ln of C0, which is a constant, minus ln of exponential is by itself minus KT. So that's number 3. Then the if we are interested in ln, log of concentration is now becoming the first order function over t. So this will be easier to draw how as a linear graph. So over time, so this is semi-log plot, ln and c is C0. So depending on this, different k, and this becomes a linear graph. So which this will be used that if the reaction is really linearly first order reaction, if we want to confirm it, we can draw the experimental data over T over a log of concentration and see if this graph looks like linear. Okay, so we'll stop it here and then move on. Now, I want to discuss one more time about the aspirin problem. So this is quite relevant for us. So those who have any family member who suffer from a fever, then we take aspirin. So the half-life of aspirin, or acetylsalicylic acid, is known to be about 15 minutes. If 10 units of aspirin is orally administered, then how long does it take for this body to contain 2 units of aspirin by having known this half-life of aspirin? And you remember, if you actually use the tablet, will have about 300 to 600 milligram. And we don't take it like every 15 minutes. We are supposed to take it like every 6 hours. Then the question, how the biological effects of aspirin can last for several hours. So that's, we want to discuss it here. And let's see our board exercise. Okay, so the aspirin problem. So now given the half-life of aspirin, let's say, is 15 minutes. And we wonder if how long does it take for aspirin to 10 units become 2 units in our body. So let's see. So from what we know from the previous part, the proportionality constant K is defined as ln2 over tau. So we can write it ln2 over 15 minutes. Okay, so then the concentration, so let's see, CT equals C0 times e to the minus KT. So then the concentration of C, let's say D prime over C0 will be 10 units become 2 units. That will be, the time will be e to the minus KT prime, let's say. Then how can we calculate this? So KT prime will become ln5. ln5, or so we want to know the time of T prime will be ln5 so that ln5 divided by K, and this is 1, from 1, K equals ln2 ln5 times 15 minutes. So this you can calculate, and in fact this is about 2.32. So that will be about 3:35 minutes. Okay. So the time for the concentration become 10 to 2 units, which is 5 times lower. It takes about 35 minutes. Then if the 2 unit is effective concentration for aspirin to our body, then it only takes about 35 minutes. Then the efficacy of aspirin will not be effective enough. So that if I write it down in this graph, like, so 10 units, and so it's exponentially decaying and becomes 2 units. And what it means, it takes only about 35 minutes. And of course, half-life is 15 minutes. So how come the aspirin can be used last for several hours? And the answer is the biological effect will last as long as the concentration is above the therapeutic concentration. So we just have U as a very high and high, then therapeutic. So this is concentration. Therapeutic concentration can last for several hours by putting a huge dose of initial dose. So if large dose is administered, then the effect can last as far as the concentration is above the therapeutic dose. Of course, this has to happen assuming if this initial dose is not toxic. So aspirin is in fact, that's the case. Okay, so thanks for your attention, and this is, we will move on to next time for the another physiological system.